start the live stream, and got a few more people. Good. So let's first get us that should work. So what should we have for our word of the day for attendance? What's the first word that came into your mind when you woke up this morning? Breakfast. All right. So we'll use breakfast.
I think we already used that one.
So we'll do breakfast too. Okay. That's usually the first thing that comes to my mind too. Breakfast. Breakfast is fine. We can use it more than once. It's good. We like to eat breakfast more than once, yes. So, where we're at is, so I'm just looking at the syllabus. And again, occasionally I get questions about points and stuff. Everything's really in the syllabus, so don't forget about it. It's there. And let's see, where are we today? Last week we finished up chapter 12. So this is the week of February 26th, although this is March 1st. This started off with February 26th. So we're going to take a look at chapter 4, which is on percentages. And if you watched any of the videos of me working problems from chapter 8, which was probability, you would have really gotten a good feel for percentages as well, because I took every fraction, turned it to a decimal, turned it to a percent. And so this hopefully will be a nice sort of a refreshing chapter, tying you back into what we did with 8. And if you struggled with 8, maybe after today you could go back and you might find 8 easier as well. Okay. Next week is the last week before spring break, and we'll start in with the unit on savings, which is one of the most, maybe the most useful part of this class. I've had a number of students who after this, they went to their employers and such, and because they had 401k plans, but they never really knew the importance of it. But they start seeing ways to basically to take control of their finances. So that's a good one. And then after spring break, we'll bring back annuities and loans, which is the other side of financial math. Okay. Over spring break, we will not be meeting. I think campus is closed as far as I know. So during the week of March 12th, we'll take a little break, and then we'll finish off. And then after spring break, we do the financial, and then there's a few, I think there's 4 chapters. There's chapter 7, 3, 2, and 1, and they're all kind of a little different. Okay. And actually, I just looked. I think chapter 7 is Venn diagrams, and chapter 3 is linear functions. So if you see these, I think this should go down here, and that goes up there. So a little error in the syllabus, but we'll figure that one out when we get there. So today, chapter 4. Any questions on things that have been going on, or any issues with grades? I think I did a big update this last weekend, and I did change some of the formulas. Last semester I did, I think, 20 points and 20 points, 20 for homework, 20 for the test. This semester I went back to, I think, 25 for the homework and 15 for the test. So I think I've got all so you may have seen your test scores, the points in Canvas drop, but your homework scores hopefully should have went up. But the total should still be there. Okay? Let me just do a check. this down. Clear the screen, and we'll take a look at what's in there. So percentages. We do have a class PowerPoint notes. We have the signed reading, just like normal, the reading quiz, the homework, and then the test will open up. Let's see what we get for PowerPoint. Let's just go ahead and walk through this PowerPoint. It's got some of the types of questions, and now this particular PowerPoint was made up by someone else who does the Math AS portion of the questions and such. So it relates pretty closely to the questions that are in the homework. So in this section, although it's primarily talking about percentages, part of the reason we bring in the percentages is we're also going to be talking about the mathematical process of exponential functions. Okay. Now in this one they also talk about linear functions, because that's what chapter 3 is about. Again, we're going to do chapter 3 later, so I'm going to skip over most of the stuff that deals with the linear functions, but linear functions deal with a change that is the same amount of change. Like if you were to get a raise of $5 an hour, that's an amount change. If you get a percent change, like 5% of your salary increase, that's exponential. Okay, so that's what we're going to be working with today, is exponential change. And notice what we do is the exponent really tells us how many times we repeat the multiplication of the base. The percentage is going to be contained in the base. Okay. So before we get too much further, at the beginning, when we start some sort of project, and this is kind of where exponentials come in, how much stuff do we have? What percent of the stuff that we have do we have at the beginning? Which is kind of a weird way to ask it, but at the beginning, how much do we have? What's that? Good. It seems weird, but exactly, whatever we have is 100% of what we have, right? So that's the nice thing about the percentage. It doesn't matter if we have $1 million or if we have $100. That's 100% of what we have. So what we're always thinking of is with exponentials, we always start with 100%. On probabilities, 100% means a sure thing. It's going to happen, 100% chance. 100% is everything. When we were doing probabilities, the totals of something happening was always 100% because that's everything. So everything we got is 100%. What's going to happen is as we go forward, if there's any change, we're either going to get more or we're going to get less, right? So if we're going to grow, growth is going to look like we're going to have 100% plus the amount of the growth. Let's say 25%. So we're quickly going to see when we talk about growth, a 25% growth, the mathematics behind it is we're really thinking of 125%. That's the math we're going to use to do a 25% growth. So far, so good? Make sense? Okay. If we're losing things, we're decaying or decreasing. Decay sounds kind of like a smelly process or something, you know. Things decay. We still start with the 100%, but what do we do with the, if we're losing 25%, we subtract it, right? So that's, but we're subtracting a percentage, and so the mathematics is, what we focus on is really we're getting back 75%. We're losing 25%, we're getting back 75%. Okay? So that's how we can really spot an increase or a decrease. The other part of the mathematics is we don't do mathematics directly with percentages. What do? We turn them into decimals. How do we turn a percent into a decimal? Is that close? Divide by, this is the one we divide by 100. You're right, multiply or divide by 100. So this one, from a percent to a decimal, we divide by 100. A decimal to a percent, we multiply. So good. So we're going to take both of these, divide them by 100. I think there's a couple slides where we get more detail. But so the mathematics is, an increase will be something that looks like 1.25. A decrease will be 0.75. And again, to make them exponential, we'll have an exponent, and generally the exponent will be time, how many years or something. So this is growth over several years. It's we keep multiplying by 1.25. That's growth. If we're decaying each year, we multiply by 0.75 and we lose 25% a year. Okay? So if you can kind of keep that intact, that we're with this unit, we're really just adding to 100 or subtracting from 100, depending upon whether our rate is increasing, a positive rate, or decreasing, a negative rate. Okay, so deal with the percentages first, and it should go pretty smoothly. So let's see this one. Page. Okay. Now, along with this is a way of thinking of a percentage as a part over a whole. I'm going to show you sort of that uses this, but maybe a little bit further. I'm going to, because I found that doing percentages as proportions is really helpful. So part over the whole is a proportion that's equal to percent over 100. Okay. So they got part equals percent times the whole, and it works. So everything they have in here will work, but I think if you follow this route, the nice part is that this all works with cross multiplying and dividing. Okay, so let me do it right here. So if I have, might have done this before, but let's just do this. 3/4. What's an equivalent fraction to 3/4? 6/8, right? Okay, so let's go ahead. So we know those are equivalent. 3 times 2 is 6, 3 times 4 is 8. So these are equivalent fractions. What happens when we cross multiply these? We take 6 times 4 and 3 times 8. Don't we get the same number? 6 times 4 is 24, 3 times 8 is 24. And again, while we just looked at one example, we could look at a lot of other examples, we'd find that this always works. Where we're going to use it here is watch what happens if we had one side, say 3/4, and we were missing a part, but we had this part here. What we're going to do is, I call this just cross multiply and divide. So instead of trying to do it algebraically with everything, we're going to multiply the two across that we can. So we're going to take 3 times 8, or 8 times 3 since we started with the 8. Either one works. And then the one that's out here, the one that doesn't have a partner, the part we know of, we're going to divide by that. So we cross 3 times 8, divide by 4. So what you'll see is that there's a very straightforward way of this is all sort of just arithmetic. Multiply the two are across, 2 times 3 is 24. Then divide by 4, and we get our 6, which again from the first problem, we know that x was supposed to be 6. Okay, so this is the way I'm going to show you how to do each of these problems. And I'll just say if you're comfortable with percentages, but you do it in slightly a different process and it works, go ahead and stick with it. But if you've had struggles with percentages, maybe give this a try and it might be helpful. So in a survey, 243 people out of 400 state that they like dogs. What percent is this? So all we got to decide is, we've got two numbers, which one's the part and which one's the whole. Does anyone help me with that one? 243. Usually your part's going to be smaller. Not always. Sometimes you get over 100%, but right, it's usually 243 out of 400, so 243 is the part out of 400. And what that is it's equal to the percent over 100. So what we do is we're going to cross multiply and then divide. Okay. Now, there's other ways you could do it. You could do it in a different order. You could divide and then multiply by 100, but if you remember everything correctly. Okay. But I've just naturally take our 100 times 243, and then we'll divide by 400. It'll always work. And this gives us a percentage. We don't have to change it from a percent to a decimal or decimal. It's going to give us the percent. So, let's see. The other thing I need is a little calculator would be helpful. Come on. There it is. Bring that over. And then we just enter this 100 times 243 divided by 100. What did I do? Oh, 400. Thank you. Yeah. Why did I get back to what I started with, right? Okay, so still got to put the right numbers in. 100 times 243 divided by 400. 60.75, and that is our percentage. Okay. And again, you may have learned a different way of doing it, and if you're comfortable with it, great. But I oftentimes find that when people do it the other way, they take 243 divided by 100 or 400, and then they get mixed up of which way do I move the decimal and those kind of things. This little system will take care of everything. And then once you get used to this system, you'll pick up shortcuts on your own that work with the way you see it. I think this is a way that'll do it if you set up every problem this way. So far, so good? Questions? Okay. Save that one. So then I forgot the PowerPoint kind of walks you through it. They tell you the part and the whole, but we already figured that one out ourselves, right? And then they divide, and then they move it into a percentage, which is the same number we got, right? And it works for some people, but I also find that people will forget in certain situations which way to move the decimal, and so we'll just kind of keep working these with our part over whole equals percent over 100. Okay, and then we'll take a look at how they work them as well. Okay, so sales tax in a town is 9.4%. So when you see a percent, where does the percent go? This is the cool part. This part over whole equals percent over 100. The cool part about this, 100 is always 100. So it's always going to be there. When they give us a percent, it goes in the percent. And then we just have to figure out is the other number, because again, they always got to give us two things. You got to figure out this number, is it a part or is it a whole? So we put the 9.4%, put the 100, and notice I haven't even really read this yet, so now I better read. The sales tax in the town is 9.4%. How much tax will you pay on a $140 purchase? So is the tax part of the purchase, or is the purchase part of the tax? Fortunately, the tax is still smaller than the purchase. Again, you go to Thailand, they'll actually, if you import a car in Thailand, they charge you 300% tax. So a $10,000 car, you'll put $30,000 in taxes to buy a $10,000. That's, yeah. You want to buy a domestic, but if you buy domestically, you're okay. So don't import a car when you're in Thailand. So the 140 is the whole. And up here is going to be the missing number, and that's going to be our tax. And again, we don't have to worry about whether we're multiplying, dividing, which is really all we're doing with these, but this gives us a method that what we're going to do is we're going to take 9.4 times 140, and then we'll divide by 100. It just shows us a visual. Why 140 is in the bottom? Okay, because the question is the two things we're looking for is how much tax will you pay on a $140 purchase. So the purchase is the whole value. It's the thing that we're buying, right? When you buy a shirt, let's say it was $40. It's the part that the tax is going to be based on that whole part. Okay. I don't know if that's a good explanation or not, but then we'll add the tax on to it, and the tax is a percentage based on this number. It's a percent. The other part, as you can think of it, it certainly should be less than 140. So when we look at this relationship, 9.4 is less than 100. So this fraction has to have a smaller top than a bottom. If this was like 194% where the top was bigger than the bottom, then we would also say, okay, the top has to be bigger than the bottom of the other one. Okay, so these are proportional. So we just go 140 times 9.4. And notice this method, we don't have to worry about moving decimal places, which I find is something that can be very confusing, or can be the area where the problems are caused. We just cross multiply and divide. and the setup's always there. So it's going to be 140 times 9.4, and then we divide it by 100. 13.6. That is the amount of the tax. It's not a percentage. So our tax will be $13.16. And again, 9% is close to 10. You could, if you estimated 10% of 140, you'd be right, it's about $14. So you could do a kind of a second check on it. That's the amount of our tax. Okay. Does that make sense? This part. And again, sometimes I do this a lot. Is once I know how to do a problem, if I'm not quite sure, I do it the other way and see if if the answer makes sense. And if we put the 140 in the top and did it, I think we'd end up with like 1,316 or something. We'd end up with a really big number, and we said, that's way too much tax. Okay, but sometimes you can do it that way. Clear this off, and then let's see if the PowerPoint walks us through. I think it does. So the whole and the part is the tax. And again, after a while, you just kind of think about it as the tax is based on the purchase price. And then again, this is in MAT141, so you're welcome to look through it. They kind of do it in a different style. It might be what you're used to, and if it's what you're comfortable with, that's great. But I just try to give you an alternate means. If you struggled with percentages, try my way of just doing a proportion. It'll work all the time. I started doing a class to help with the GRE, and I found that's all I used. I used proportions, and it takes care of about 30% of that exam. And it's a real simple method that solves a lot of problems. And I didn't always use this sometimes, but I'm using it every time where I can, and I'm finding that simple proportion, it solves a lot of ordinary problems that were harder to solve by a different means. And I did this, a few of them, I worked on them, and I remember those problems took me like 10 minutes to work through. And now 2 years later, I'm working those same problems with a proportion. I go, they're so simple when you look at it as a proportion problem, and I'm done within a minute. The same problems that I took me, and it's not just because I worked them before, because I forgot about them. It's just I used algebra, and algebra sometimes it's hard. It's harder than it needs to be when we can do a proportion. Okay? Good. So let's take a look at this one. We'll do it our way or my way. It might not be your way yet, but we're just going to keep working with it, and I'll just show you that this gives us a simple way. Okay, a lender requires a minimum down payment of 12%, the value of the home. You have $22,020 cash available to use as a down payment towards a home. Determine the maximum home value you can finance. Okay, so the cool part is when we recognize this, and I'll just keep writing the proportion. We've got part over the whole equals percent over 100. Notice there's only 3 places to put things. They gave us something with a percent, so we know that this percent part is going to be replaced with 12. And so now we've got this fraction. We're going to either have the top or the bottom. So what is going to be the part? What's going to be the whole? Well, $22,000 available as a down payment. A down payment is what in relationship to the price of a home? Is it all the price of the home? No, that means you're paying cash. It's part of the price of the home, and then you're going to borrow the rest, right? So does it make sense that the $22,020 is a part? And what we're looking for is how much house can we buy if that's what we have our down payment. Okay. And if we do it this way, then what's the math? 100 divided by 12. See, this lays it out every time. And if we lay this out algebraically, I'll tell you half the time I do it wrong, and then I have to redo it the other way, because I know it's either multiply or divide by something, but sometimes I'm not quite sure. But when I lay it out this way, it's very clear. The ones that are kitty corner from each other, that are diagonal, we multiply those, and then we divide by the odd one. It's just always going to be that way. So yeah, 22,020 times 100 divided by 12. And that will give us our value. And the thing that's sort of weird that feels weird about this one is the number's going to be bigger, but shouldn't it be bigger? And sometimes it just feels when we're doing percentages we should get less, but this is definitely one where the down payment is just a part. So we multiply it by 100. Wow, $2 million house, but we're not done yet. Divided by 12. Can't buy the $2 million house, but we could buy a $183,000 house. Okay. $183,000 house. 500. And again, the 22,000 is our down payment, so we won't borrow 183,000. This we'll start doing when we get to lesson 6 about loans, because we do home loans. That's the other part, is we do some parts on borrowing to buy a house and all the things involved in that. So if we buy a house for 183, we got the down payment, which is 12%. We will borrow the rest. We subtract it. That's going to put us about 161,000, something like that. So we're going to have to borrow around 161,000, but we could get $183,000. So it's always good. So we shouldn't be. That's all we got, right? We shouldn't be shopping for a $400,000 house. So we're not, unless they'll let us do it with 6% down or something. But okay, does that make sense? Does this method sort of? Yeah, we're just cross-multiplying two numbers, and then we're dividing by the third one. That's all this does. Simple, but elegant. This is, what page am I on? Page 5. There we go. Okay, so let's do this, and then we'll see what the PowerPoint tells us to do. I'm sure we come up with the same answer, but notice they do it a slightly different way. They're taking 12% of the value, then you divide by it. It's still got the 183.5. So again, I gave you both systems. You can use the way the PowerPoint has them going, which is fine, and it might be more familiar and comfortable to you. That's great. But I also give a method for those who maybe have some problems with it, like me, because I'm dyslexic, and that's my problem. I know I'm either multiplying or dividing, but half the time I do the wrong thing, and then I have to recorrect myself. That's how I did most of my math. And so it was actually a student that showed me is over of equals percent over 100 about 5 years ago, explained it to me. I understood it, and that's why I do everything with a proportion now, because it actually helped me teach it a lot more clearly than trying to explain this. I could, yeah. Okay. So far, so good. Remember that little proportion, and it takes care of just about everything. Let's just keep going. Now with this one, we're going to see, I've seen this done in two different ways. And again, I'm going to show you one way that's sort of based upon what we did. This is relative change or percent change. And there's kind of two different things we can do with these, but there is, when we're given two quantities, we want to know the percent change from one to the other. One thing is that the change has occurred because of time. And so that's true. You have two quantities, an ending quantity and a starting quantity. What I like to do is I refer to those as the new value, so that's what we have now, right? That's the new value. And then what we'll do is we subtract off the old value. Now, if the new value is bigger than the old value, what kind of value do we have? We have $100 now, and we started with 5 or 50. We'll have 50 positive dollars, right? If the new is smaller than the old, we end up with a negative value because we lost something, and we'll see it'll come off as a negative percent. To turn this into a percent, what we have to do is we have to divide by what we're referencing, and we always are really looking for the percent in relation to what we started with, the old value. So I just think new minus the old over the old, if you can remember that, that does everything. And then instead of setting up the proportion, what we always, because since we're looking for the percent, we'll always end up multiplying by 100. Okay, and that comes from the percentage. But instead of setting it all up, this is all we have to remember to do. New minus the old, divide by the old, multiply by 100. And we'll have our percentage for all of them. And it doesn't matter whether it's a percent increase or decrease, we do it exactly the same way. Just the result will be negative if it was a decrease, and it'll be positive if it's an increase. But I've seen books where they switch this order depending upon whether it's increase or decrease. I say, don't worry about that. It all comes out in the wash. And when you get a negative on something, you know it was a decrease, and a positive will give you an increase. Okay, so they sort of go through the whole thing too. Let's see, I don't think, let's see what else. Okay. So let's go ahead and calculate these. So quantity decreases from 50 to 40. So which one is the new, which one's the old? Which one? From 50. From is what we had. Yeah, so it's the older. This is why it's easier. We went from that, so that's the older one. So this is the hard. I mean, this is the key part. And then 240, so that's the new one. And so what we do is we follow that formula. It's kind of hidden up, but it's going to be 40 minus 50 divided by 50. Oops, yep, right, old. And then we multiply by 100. The key part here is when you're doing it on the calculator, is you got to do sort of order of operations. Clear this. You have to do the 40 minus the 50. You have to hit the enter key to have that happen first. Okay, and then divide by the 50. Enter, and then multiply by 100. And notice we got a negative 20. That's a negative 20%. And what we do, like with Math AS, since we're calling it a percent decrease already, we could just list it as a 20%. We don't have to put the negative because we're saying it's a decrease. 20%, and I'll just put the words here. But yes, our answer does have the negative on it because it was a decrease. So that's that way. So when we have a quantity increase, again, from 40 to 50, now which one is the old and which one's the new? Forty is the old because that's what we came from. We went to 50, that's the new. A little bit darker. Let's go with blue this time. And again, we just follow that formula, new minus the old, so that's going to be, in this case, 50 minus 40 divided by the old. And that's the key part. The subtraction part's not really a problem. We'll subtract them, we'll get the difference. But what do we divide by? We always have to divide by the old, okay, the thing we're referencing. And again, we multiply by 100. So this one, actually we get sort of the same value, don't we? At least for the top part. It's 10, it's a difference of 10. So let's go clear 50 minus 40, enter, but it's a positive 10. It's an increase of 10. But watch, it's not going to be 20%, is it? We're going to divide not by 50, but divide by 40. 0.25 times 100, that's actually a 25% increase because we went from 40 to 50. And that's kind of the weird part of percentages is that a percent markup by the same amount, you mark it up $10 or mark it down $10, the percentage is different. Okay? So you can't mark something up 20% and then mark it down 20%. You don't arrive back at the same place. So that's, yeah, you can mark it up 20%, then put it on a 20% off sale, and you're actually making some money off of it. Okay. So again, we just put this as a 25%. And since it's positive, we know this is an increase. Okay. But again, just a simple formula, new minus the old divided by the old. Say it enough times and you'll carry this with you. And these are the types of things we use again and again. When we get to chapter 5, we're going to talk about something called total return. This formula will come back to us. So we'll use it again in chapter 5. And again, with financial things, they do talk about total return. That's all it is. Okay. So far, so good? Oops, no, I want to go this way. There we go. And then let's see if they work through it for us. They don't, so it's a good thing we did this. Okay, and then we've got several problems. There's 3 of them here. Does anyone want to look at one in particular? Or do you want to move forward? It's up to you.
Is there like a tricky one?
Not for me. The tricky part, we could just identify, but is there one that looks tricky to you? Not really. It really is just as simple as identifying the new and the old. And I guess we could do that kind of quickly without too much effort. Oops. Let's do this in a dark blue. So latte dropped from this to that. So what's the new? What's the old? Makes sense that this one would be the old. That's what it was. This is the new. Use the formula, we get a percent, right? New minus the old divided by the old. And then multiply by 100 to turn it to a percentage. It's always, 100's always in there someplace. How about Teresa's annual income increased from 2? It's not 2. Whenever you say from something, that's always older, right? It was the start. There's the old. Here's the new. Nothing to it. Sure, it was originally beginning, right? Original, that's got to be the old. It rings up at the register. That's obviously after, that's down the road. That's the new. New minus the old divided by the old. Simple. Just little formula, and it works all the way through. Okay, so that proportion, part over the whole, percent over 100. Just do everything with percentage of that proportion, and then when we have a percent change, because we've got time involved, sort of a third thing, we just use this new minus the old over the old, and it's like it's hard to make mistakes now. I still can do it, but it's harder to make mistakes than to do it right, actually. but you'll see me. I can, yeah. Okay, so identify them, put them in the formula, got your answers. Let's see, let's go here. And as I remember, some of these are, they come from some of the reading quiz problems will be here. Like some of these are homework type problems as well, because the person who made up this PowerPoint was the one who made up those problems. Percent increase, percent decrease. What we're going to see is this is really sort of what we've already talked about. Okay, so, but we're just going to think of it a little bit different. Okay, so they're going to walk you through this, but I'm going to take you to the shortcut. In the news, you hear that tuition expected to increase by 7%. Okay, if tuition this year was $1,200 per semester, what will it be next year? The key part is we'll use our proportion, but they want to know the total new tuition, right? So how could we calculate that correct or directly? Well, what was the old tuition? It's $1,200 per semester. As a percentage, what was it? What do we? What? Yeah, 100%. Because it's what's 1,200 of 1,200. It was the whole cost. So what you want to think about this, if we increased or decreased, what we did is we always start with 100%. And in this case, we're adding, this is kind of taking us back, we're adding the 7%. So really what we want to do to get the calculation, we don't want, now if we wanted what the additional amount is, we could do that calculation separately as 7%. But if we just do the calculation to get to the total, watch this. We use 107%. Okay. So what that gives us is it gives us the percentage, right? I said part over whole equals percent over 100. And this is where it kind of helps out. So what we're going to use is we're going to use 107% over 100. This is where it gets a little dicey. What is the whole? 1,200. That goes down here. The part is actually the new amount, but we can see it's got to be more than 1,200 because 107 is bigger than 100. This proportion will work out. This will give us our new tuition right here.
So if it's asking for the increase of something, is that usually the numerator has a bigger number?
Yes, it's going to be a bigger number because it increased. If they discounted by 7%, then we would have just take 100 minus 7, and then we would be using 93%. Okay, but it saves us that middle step of calculating the actual amount of the increase or decrease. Okay, and we'll do that with like 30% off sale on a shirt. Yes, you could calculate the 30% off and then subtract it, or you could just work with 70% and get the value at the end. Okay, so I'm going to do it this way, and we'll see that we end up with the same value that they've already come up with, right? We would take 107 times 1,200 and then divide it by 100. Okay, and watch, we're going to get the answer in a single step, because you think you could, if we're working with percentages, you think you could take 100 plus 7 in your head? And most of you probably will. Okay, you won't even write this down. You'll just think, well, that's 107%. Okay, so let's clear this. 107 times 1,200, and then we divide it by 100. And we get 1,284, which is what they got by doing it, going through. They found the 7%, which was 84, and added it on. But it's a lot easier. 1,200 plus 84, I guess that wasn't too hard. But a lot of times if you do the percents first, you get numbers that are not real easy to work with mentally, so you have to use a calculator or else you're going to make a mistake. When you work with the percentages in the first part, usually those are easy. 100 plus 7, that's a very easy calculation. 1200 plus 84 is not that hard, but it's harder than 100 plus 7. It will always be this way, I guarantee you. And usually it's a lot harder. Okay, so we got the 1284 there. We'll just write it down. So our new payment is 1284. Okay. And again, we're not doing any rocket science or we're not doing anything. We're just doing it. We're doing the calculations in a non-standard order. Okay. We're not necessarily, but it works because when you add two numbers, does it matter which one you add first? No, it's commutative. Multiplication, commutative. And as we're finding out, actually, you could divide first or multiply first, but you could interchange these as long as you do the right values. Okay. Awesome. Oops. Cancel. Let's make this page 8. And then I think they come in and then they look at the 100%. Again, they still do it their way. They just multiply by 1.07. And if you're comfortable with it, that's fine. But again, it's kind of moving decimal places and stuff. And I find even I make mistakes. Sometimes I move the decimal the wrong way. And if we use that proportion, it's like we don't ever have to worry about moving decimals because we get that 100%. In fact, I'll take it back one step. My wife was in a class and doing percentages, and there was a place where at the end I said, and you move the decimal over 2 places. She had the audacity to ask me why. And I was a math teacher who didn't know why anymore. You just do it because that's what you're supposed to do, right? And I felt real bad because being a math teacher, I should have been able to explain why. It took me 2 days to think about it. I said, oh, because you're dividing by 100 or you're multiplying by 100. But it was kind of like, I should have had that answer ready. And so now the way I teach it, I always have that answer ready because that's what I teach you to do. I don't teach you some mystical thing of just move the decimal 2 places because that's how they do it. You're multiplying by 100 or dividing by 100, but the system sets it up. Okay? So, it's good. Okay. Well, let's do this one. It's going to be kind of similar, and then we'll see what they do. Again, we could figure off the 35% off, but what's a better way to do this? The price of the TV was 100%. What's it going to be now? We're going to take 35% off of it. So how much are we going to pay? This is a little tricky. 65%? Okay. So 35% off sale, right? So I always just remember whatever we start with is 100%. And we're going to take 35% off of it, so 100 minus 35 gets us to 65. Does that make sense? We will. We're not done yet. Yeah. So this is just to get to the percentage that we're going to use. Good. Okay. So now we're going to use the proportion part over the whole equals, oops, that jumped ahead as well, equals percent over 100. And what I'm going to do is I'm going to use the 65% rather than the 35%. The 35% will give me the amount of the discount, but I want to know how much do I pay for this thing. And so that gets me to the answer I'm interested in faster. And so I'm going to use 65% here over 100. And then the question is the original price the part or the whole? Well, it's the whole, because I'm going to get a discount, so the top's got to be smaller than the bottom, because 65 is smaller than 100. Okay, so that kind of helps. You got the 869, and it's either going to go in the top or the bottom. And again, you could still make a mistake, but you're less likely to make mistakes this way. So we're looking for that. Cross multiply, divide. See, I don't even have to explain about moving decimal places because it's all built in here. 65 times 869, and then divide by 100. So just get these calculations down, and it makes it easier than to start maybe doing them mentally or almost just entering them into the calculator as you go. And remember, this time we're looking for a dollar amount, $564. This is what we're going to have to pay for this television. Not including tax, but it's now the list price. And we don't have to worry about how much did I save, because I really didn't save any money. I got a discount. But remember, the reason it was a discount, they probably weren't selling at the higher price. So it's not always a savings, but instead of $869, I get a buy it for $564. Okay. Direct calculation. And again, the only extra step is I did the easy subtraction here. I mean, 100 minus 35 is easier to do than if I calculated 35% and I would have had some change, right? I would have taken 869 minus, I don't know, 300 and something. I would have been busting out my calculator. I still was, but this was I had the easy chance to do an easy calculation, which I did, and it got me directly to here, instead of two hard calculations. Okay, I had one easy and one hard instead of two hard. Questions? How's that feeling? Does it make sense? Does it seem too easy? When I sat and did it, I go, man, this is so much easier. And the more I use it, the easier it becomes. And because I remember how hard some of these were, and I remember sometimes I'd have to think really for a while what I was doing. And again, sometimes even I thought it might be easy, but I would do it the wrong way. I multiplied when I should have divided, or divided when I should have multiplied, or I moved the decimal in the wrong direction or something. But when I do it this way, consistently, it just doesn't do it. So now I'm using it more and more, and it's very visual. Very visual. So let's see how they do it. I think, yeah. So they do it both ways. Notice they got $304.15 as the discount, and then you still have to subtract, and then you get it. The other way is to use the 65% as we did, and you get the answer right away. Okay. So again, those are built into the PowerPoint. If you want to look at that later, you're welcome to it. It's also in the video. So showing you two different ways to do it. I could just sit here and click through it, but I also want to show you an alternate way, which I've been doing. And the thing is you'll find that you can actually get pretty good at doing it while you're in the store. 35% discount, I probably round it to like a 30% discount because I could do it. So I'm multiplying by 7, and I can get pretty close to what I need to, what it's going to cost me, rather than trying to figure out how much discount and then hold that in my head and then do a subtraction. I can never do that. But I can get a pretty good estimate by figuring 35% off is 65% on. Okay. Percent increase, decrease, again, just a lot of more questions. The trick to all of these is to do it because they want, what is the total amount whenever we're looking for that. Well, here's an 18% tip. So again, we're going to go 100% plus the 18%. So we're going to use 118 for our calculation. Here's Sam, he lost 11%. So we're going to take 100% minus 11%. I think that gets us to like an 89% is what we're going to be using for our calculation. See how you get to the place where you can just start doing that in your mind? So 100 minus 11, that's what we're going to use. And then we use the part over whole percent, but we start with, this will get us directly to our answer. Okay. New job, Janelle expects to receive a 5% raise each year. So what's she going to do? She's going to get her salary of 100% plus the 5%. So we're going to use 105% when we do these calculations. Okay. Just add the percentages first, and you'll be fine. Cars decreasing in value. Decrease means subtract, down. 12% each year, so again, 100% minus 12%, we're going to use, is that 88% when we do our calculations. We're only getting 88% of our value back. Okay, and then go through the calculations with the part over whole, percent over 100. Okay. Do it again and again and again, and you'll develop your own shortcuts, or not, but you'll get it down, and you'll just see it's amazing. Believe me. This is a math teacher who struggles with it, so believe me, I can make math easier. It's just because of the way my mind kind of notes here. Okay, so let's here. And what we're doing is it leads us right into exponential functions. Okay, so I'm going, instead of stepping through all of these steps, which they want us to, maybe I'll go there, but okay, so I'm going to just see if we can jump to this slide and see if we can make it work. Okay, so putting everything we've done so far together. We've got this with the purchase of a new home, 120 or 200,000. Write a formula representing the value V of the home after X years, assuming that the value increases by 12%. So as we've been working through, you'll see that this is the part, remember, and another way we could characterize this when we had a sort of a change over time, that this also was always the starting value. Remember, it's the old value. So the bottom's always what we started with. So what we're going to do is we're going to take a percent times the starting value, and then we're going to divide it by 100. Okay. But what we're going to do first, if it increases by 1200, we don't want just the increase, right? We want the whole value. So if we're increasing by 12%, what kind of a percentage rate are we going to use? 100 plus the 12, so we'll use 112%. We're going to take that times the starting value, and then we're going to divide by 100. I'll show you the trick that they're doing here, and you'll need this from Math AS. We're going to take the 112% divided by 100 in here, and then they'll multiply, and then this is where the repeated multiplication goes on. So there's where the variable is. So it's the same sort of steps, but they're kind of doing them in a little bit different order, and you'll see, yes, this becomes 1.12. But this is the division part that we did. Decreases by 12% per year. What do we do first? Subtract 12%. So what we use as our percentage is 88%. We do exactly the same thing. We're starting with $200,000 value. We have 88% over 100 to the x. And you'll see, yes, that does become 0.88. So it all works in there, but you've got this, this sort of memory aid that this is exactly what's happening. You're not worrying about moving the decimal and maybe moving it the wrong way, or remembering why you're supposed to do that. And even when you're a math teacher, you can't remember why you do things. That's not good. Increases by 3% per year. Again, 100 plus 3, we're going to use 103%. And it's all the same thing. It's still 200,000 for the year. We just use our 103 divided by 100, because that's what we always do, raised to the x power. Okay. Decreases by 3, minus 3, so that's going to be 97%. So do the easy calculation first. Subtract it from 100, add it to 100, whichever way, if it's increasing, decreasing. And then this just reminds us we divide it by 100, turn it to a decimal, and there we are. These get a little tricky, the 2.5. Use a calculator. Again, we're either adding to 100, that one's not too bad, 102.5%, or subtracting, which is a little trickier, that's 97.5%, I think. Did I get that one right? Okay, and again, set them up, and you're ready to go. Perfect, right? We're almost done. Let's take a picture. New page. And then they start giving, if we've got the equations, let's maybe go through this one, and then I think we're good for the day, which is fun. So what's our initial value when we look at this equation? 30. So the number in front, remember this has the percentage in there. Is it growth or decay? Well, it's above 1. Remember, we start to think of this as 115%. So to get back to a percentage, we multiply by 100.
So all of these ones like in this table,
No, let's because it doesn't have the. I'll show you where the negative comes in. Good question though. So then to get the rate, what we do is we take the rate that we have. And remember, if it was a 15% growth, we took 100 plus 15. So to get the actual rate, we subtract off the 100 here. And that gives us a 15%. So 115 minus 100 gives us positive 15%. Let's drop down to here, because this will be the same thing. But starting value is 500. Before we talk about growth or decay, let's talk about this. This is like, if we multiply by 100, we get 90%. Okay. If we take 90%, and remember, to get there, we had to add 100. We subtract off 100. What do we get? We get a negative 10%. So we call it a 10% decay. We're losing it. And then we don't use the negative. But that's where the negative comes in, is we take the rate minus 100. That's where we're going to see it's a decay. It's kind of backwards, but in this one we can see we've got 75% minus the 100. We're decreasing by 25%. Okay, so that's definitely decay as well. 58 there. And then we can see up here, right? That's 1.2. Hopefully after doing this enough, you see that's 120%. Subtract off the 100, that's a 20% increase, growth. And we start with 3.2, we've got growth. Okay. I should do. I just taught this in my MAT141, and it seemed a lot harder because we took an algebraic approach to all this. And I think if we would have done this, maybe I better just change what I'm doing with it. Just change that curriculum too. I don't know. How are you guys feeling? Does it feel? Yeah, you're either really good actors, but it looks like you're all understanding. Nobody. Usually, I can tell when people fall asleep or leave, or it's okay if you leave. Page 12. See, we're almost there. Let's and then we get, we could do some of these graphs. This is what I don't particularly care for. All this stuff is what we've been doing anyway, so we don't have to necessarily. This is what probably made the 120 difficult to deal with. We're just going to do a lot of calculations. We're not going to use the graphing parts of it. And let's see. These are good ones to go through. Let me go back. And you want to take a look at any of these in particular, how to set them up. Yeah, you set up the equation, and then you just figure out how many years, you put that in the exponent, and then you use, let's just do this one real quick, we'll see. Using our method, okay, we know the year we're starting is 1985. Wow, 36 billion was spent on credit cards, that's a lot. Amount of credit card spending from Thanksgiving to Christmas has increased at a constant rate of 12% per year. So every year since 1985, a 12% increase. So what percent are we going to be using? 100% plus 12. So just remember, when they say a percent increase, just add it to 100, because that's what we always start with. So we're going to be using 112%. Okay. Write a formula for the, should be a T there. The amount of credit card spending, A, in billions of dollars as a function of X, the number of years. So we started out, again, starting value, 36 billion. And then remember here, it's the percentage over 100. Or you could just write 1.12 if you get to that level. And there's an X there. That's our formula. And then we just want to know how much were people spending in 1991. So we just have to figure out how many years passed between 85 to 91. And I find the quickest way to do that, unless I use my fingers, which is you just subtract, 1985. That's 6 years. Okay, yeah. I guess that wasn't too bad. I could use my fingers on that one. I thought it was going to be more. That's just 6 years difference. So what we do is we take our formula, 36 million, 1.12, and then we raise it to the 6th power. Now the problem is on this standard calculator, it doesn't have an exponent. So for that, you just need to make sure you switch over to the scientific calculator. And you just plug it in, 36 times 1.12, and there's an exponent somewhere. Where's the exponent key? Here, x to the y. Raise that to the 6, and I think we hit enter. Is that right? Yeah, this, I'm not, okay, let's try this. Let's do this first. Let's do the 1.12 first. Raise it to the 6th power. We get that times 36. I still got the 71.
I initially got 1.97.
1.97?
Yeah, and then times 36.
Yes.
I got some. Yeah, I got some.
You got a rounding because I didn't round it, so we're close enough.
Okay.
So yeah, if you rounded it first, we're close enough. $71 billion. It's pretty big. Okay. And again, you might have a little bit of rounding difference, but that's okay. And does anyone know what the credit card fee is? When you use your credit card, do you know how that works? Okay. You buy something for $100. Put on your credit card. Does the retailer get $100? The thing is, no. There's a fee that they pay when you use your credit card. They actually only get, it's usually, it depends on the volume, but let's say it's 3%. It's close. It's like 2 or 3%. The retailer's only going to get $97. You're going to get charged $100 on your card. Where does that $3 go? It didn't go to the retailer. It went to the credit card company. So this is how credit card companies make most of their money. And then what do? They charge you 25, 26% on top of that. So if you don't get it paid off, they're also making money off of you. So they make money the second you make the purchase. They get 2, 3%. It doesn't sound like a great deal, but when you're talking $71 billion, what's 3% of 71 billion? I figured that out. It's a lot. They get that at the beginning, plus you don't pay it off because you spent so much money you can't pay it all off, so now you're paying interest on it at 24% a year. If you have the money, open a credit card company because they're the ones who make the money. It's crazy. And that's why people come up with these things like bitcoins. They're trying to make electronic money where somebody isn't always getting a fee. But yeah, with credit cards, the credit card, this processing, and it's all electronic. I don't know, maybe they have to pay something, but somebody's getting rich. And it's not you and it's not me. And it's not necessarily the retailers because they're having to give up, but they gladly give up their 3% because if they don't, if they just take cash, a lot of people won't buy. Right? So that's what they do. And the other thing is like Macy's and these department stores, they make their own credit cards so that they can get access to that. That's why they want you to use their store card rather than your Visa, because otherwise they have to pay Visa 2%, 3%, whatever it is. That's what we're going to do next lesson. Is we're going to start unveiling all this mystery of the financial part of math, and you'll just be amazed. It'll give you two things. Once you start understanding how interest works, these percentages, it works both ways. It's very powerful when it works for you. It's also powerful when it works against you. So once you get in debt, it's really hard to get out of debt because the interest is it's an extra weight on you. But once you get above that and you're actually able to be the one that invests money and lends it to people, then it's like that just builds. That's why the rich get richer and the poor get poorer. Part of it is morality. I know there's a moral issue here of how rich should a rich person get, but there's also a law of nature, a law of interest, that this is how finances work. And so once you understand it, you'll understand how to break the cycle of being the one that's always in debt and how to break that so that you can be on the side where it's helping you, and then you can help others out rather than being the one that says, I'm going to get what I can get out of this and I don't care about anyone else, and I'm sure I got $1 billion, but I want 10 billion. I'm comfortable now, right? So maybe I can make a nonprofit that helps other people out of this situation. Maybe we could get everybody out of there. Again, there is a limit, so it is a little bit of a social issue. We do have to get some of the ultra wealthy to give up their wealth, because do they really need 7 mansions that some of them they never go see? They could give one of them to us, right? We'd take good care of it. We'd share it. But part of this is we can make this all happen if we're aware of the system, and then we start putting our money. But we all have to do it together. There's power in numbers, but when you're on the bottom half of it, there's a lot of us that are down here. But if we all work together with the way we use our money, we can change the system. We don't have to have a revolution, at least not a violent revolution, but we can do it with the way we use our money and the way we help others to learn about how they use their money. So this is, to me, I used to be in financial planning, and the reason I got out of financial planning was I was getting wealthy, and I was helping a lot, and we started off helping a lot of working, blue-collar workers save some money. But in 10 years, I was helping a lot of those same people that become very wealthy. I was helping the wealthy stay wealthy. I don't have anything against that, but it just didn't feel as exciting as helping people who were struggling to become non-struggling anymore. And that's why I came into education. So that's why I like this class so much, is because the next few units we take this power of what interest does, and this is sort of like a law of nature. If you can get interest on your money, it'll help you. If you have to pay interest on your money, it will hurt you. And we just get you to make the decisions so that you can be in the place where the money, the interest is helping you rather than hurting you. And then that you could then maybe help others. And it really takes just a little bit of adjustment. That's the cool part of this whole thing. And it takes turning off the television and not watching so many of those ads that tell us we need all these things we don't really need. And not getting, I really need that thing. I've never had one of those fancy back scratchers or something. Got somebody who could scratch my back, right? So there's a lot of small adjustments we can make to make the system work for us as well. And not just for us, but our family, all those people that are around us, all of us that are just struggling to make it from paycheck to paycheck. We can turn that all around with this mathematics by understanding. So that's why I'm really excited about the next few weeks. So we'll have next Friday, we'll look at how this interest applies to savings first off, so that we can learn how to do it for ourselves. We'll look after spring break how it applies to loans, and we'll see how much money those banks are really making off these mortgage loans. You'll see, and I've got people, the first time they do the calculation, they're almost disgusted, because they'll see you bought a house for $100, you'll pay over double, sometimes 3 times of what you bought it for. Now it's over time and stuff, but yes, that's the way interest works. And so if we put these two lessons together, we'll learn how to control it so that we're the ones in more control. And we get to do the things we want to do with our lives, rather than being stuck in a job that we hate. I'll tell you about my friend Lester, a 70-year-old guy on Social Security who he went 2 days a week, he was still a bookkeeper. He hated being a bookkeeper because he had to go. He did his whole life and all I can remember, I'd go meet Lester for coffee. I was in my 20s, he was 70. He taught me enough that I don't want to be a guy who's 70 years old and having to go keep somebody else's books because I didn't save enough for, and he served our nation. He was in World War II, he was a paratrooper, and almost gave his life. He said a Nazi soldier looked right at him and just left him because he had a broken ankle. I guess thought he would die anyway or something, but he's got all these stories, and yet he was a 70-year-old guy having to go in to keep books for, scissors, and he hated it. I want to be working when I'm 70, but I want to be doing something I love, and I want you to be happy and working when you're 70 as well, but doing the things you want to do, not because you have to do it for money, but because you want to do it. So that's the next few weeks, and we'll be in good shape. Kind of got on my soapbox there, didn't I? But this is the reason I do math. It can do so much for us. So did I save this yet? Let me do one more save, and then we're up to 12. We are, and I think if we're not done, we're probably close enough that we can be done. I think there's more of these, So take a look at these if you want. There's a few tricky ones. I think I'll do a video of them. But again, I think I've gotten you far enough you can get through at least 85 to 90%. There might be a few little tricky ones in there. Give them a try. And then, send me questions you might have. But a lot of these we're going to be looking at as financial math, and I have an app, both online. There's one you can download to a smartphone or a tablet, and there's a built-in financial app in the TI-84 calculator as well. And I'll show you how to use all of them. I like the phone apps because usually you'll have your phone with you, and once you learn how to use it, if you go in anytime and you get faced, oh, I'm going to buy a new car today or something, you can check the calculations that people are throwing at you, because a lot of times they'll just try to, oh, I can get you this payment, but they don't talk about the interest rate or what the long-term payments are. You can figure everything else just from those apps. Okay, and you can also say, if I save an extra $5 a week, what will that do for me? The apps will do it all. So we're going to work with the financial planning tools, because when I was in financial planning, that's what we used. We didn't use the formulas that are in the book. Nobody used them. I looked them up to do it, but then you program it into Excel or something. You use the apps, and that's what this class is about: is how to be able to use math in a way that you can make good decisions in life. And so we'll show you how to do that. But other than that, I think we're pretty good. If you run into something that it seems like we didn't cover it, please do feel free to send me an email. Remember, and I just highlight this in the homework. When you get into doing a homework problem, let's see what's going on here. So let's just go to this. Remember, there's a message to the instructor about this question button. If you've already put in numbers and it doesn't give you something right, when you message me, I go into your grade book and I will see exactly what the answers you got in there. So that a lot of times helps me with something. And if you're not quite sure how to do it, just when you message me, it's helpful if when you message me up here, you put some kind of a message. And I just say that because sometimes I just get a message with nothing there. So I go, well, you obviously have a question, but I'm not sure what your question is. But something. And I can take these, I pull them up and I can do a little video. I can send you a link to the video, and then I can post that in Canvas so that others could see them too. And I'll do that when there's a good question. Occasionally I've got videos also already for these, and I'll direct you to them. I don't think I did any videos for Chapter 4 though. The reason I say that is because when I go back here, there isn't any links. So I think Chapter 4 is about where I did it over summer, and that's where I sort of ran out of, the class caught up to me before I got up to there. But I can do more of these if they're helpful. I also found that if you go back to Chapter 8, I talk a lot about percentages back in when I was talking about probabilities. So that all fits in. But again, keep in touch with me. We can kind of do office hours over the online, because I can do videos. All you got to say is, I got questions on this. How would I do this? How would I start this? And I've had some people say, I've looked at this. I had no idea how to even start. And it was some of those were the expected value calculations. And I agree, those are pretty. So I would walk through a few of them. I think I got them posted in Canvas. But if you get to something that doesn't seem quite, or seems kind of new, send it to me. That will actually help, because then I'll send you the video and I'll put it in Canvas, and it'll help others as well. Okay? So, and if you have any input, please feel free to, on the live streams or something. In fact, one question, remind me, when you ask a question, I should rephrase it, because someone did tell me that on the live stream, they oftentimes can't hear your question, and then I'm starting to answer it, but they kind of figure it out while I'm answering it. And I thought about that, and I thought every time someone asks a question, I should rephrase it so that the people on the live stream, but I forget those things because I've been interacting with you. But again, I'm wanting to improve, so any input you have is always welcome. So we'll go ahead and cut it here. Oh, word of the day. We had word of the day was breakfast.
Oh, cool.
We did, yeah. So usually I wait till the end, right? Word of the day is breakfast, and that was on the very beginning. In fact, I'll show you. The cool part is see, now I'm not only just live streaming, I figured out how to sort of take screenshots. And so I'll go back to the first screenshot, and I think I got to captured in there. Yeah, here it is. So let me drag it over here. I think I stopped recording so the people, but word of the day is will actually be the screenshot. So you could actually bypass watching the video if you weren't, you know, but you'll see usually the word of the day will be in one of the slides. So I put when I go into Canvas, I put the link to the video for the class, the live stream, and then I put all these screenshots right below it. So you've got all these kind of notes. So if you want to just kind of go through and check your notes or something, those pictures will be there. And I've got like 12 pictures of what we were doing, plus the video. So, you know, you can kind of figure where to jump into. And again, my goal is to give you more resources than you need, rather than to leave you shortchanged. So you don't have to use everything, as long as you're learning it and feeling comfortable. That's what I'm looking for. All right. Cool. So I've got office hours. I'll just hang out here until, you know, you can work on the homework and we'll do it. You can take off. Have a wonderful weekend. We'll see you next week, next Friday, and then we'll have a spring break where we'll all just chill out, hopefully.